Morning, Simi ma'am. Good morning.
Morning.
Uh, I think we'll wait for 5 minutes, 2-3 minutes.
Yep, fine, no problem.
Okay, ma'am.
प्रभजोत कुछ बच्चे वेटिंग में है शायद, उनको एडमिट कर दो, चेक कर लो एक बार. Karan, HOD ma'am has also joined. Dr. Simi Datta ma'am.
Hello, ma'am.
Ma'am, please unmute yourself.
Hello, good morning, sir. How are you?
I'm fine. How about you, ma'am?
I'm good. Thank you for sparing time for our students to enlighten our students. Thank you so much.
No problem.
I think we should start, Simi ma'am.
Hanji, Bhavna, we should start.
Yes, Arshia, formally you start the program.
Sure, ma'am. Very good and cheerful morning to all of you. To formally begin with the event, myself, Engineer Arshia Gupta, along with my coordinating team members, Dr. Bhavna Sharma, Engineer Sheetal Gandotra, and Engineer Prabjot Singh, on behalf of the Department of Computer Engineering GCET Jammu, under the banner of Azadi Ka Amrit Mahotsav, welcome Dr. Simi Datta, HOD's Computer Engineering GCET, distinguished faculty and students to the webinar on ubiquitous machine learning and its applications. Today, amongst us, we have an eminent speaker, Dr. Karan Nathwani, faculty IIT Jammu. A warm welcome to you, sir. Dr. Nathwani has vast experience in the field of speech enhancement, speech pathology, intelligibility improvement, speech recognition, underwater signal processing, machine learning, and artificial intelligence. Dr. Nathwani is presently associated with IIT Jammu. Before joining IIT Jammu, he was postdoctoral researcher in France at Telecom Paris Tech and IRNIA Nancy. He was also a research scientist at Oxford University in UK and has a lot of research publications and awards to his credit. We hope that the session shall be fruitful for all of us. In the current age of the fourth industrial revolution, the digital world has a wealth of data such as Internet of Things data, cybersecurity data, mobile data, business data, social media data, health data, etc. To intelligently analyze these data and develop the corresponding smart and automated applications, the knowledge of artificial intelligence, particularly machine learning, is the key. Machine learning has become popular in various application areas such as predictive analytics and intelligent decision making, cybersecurity and threat intelligence, traffic prediction and transportation, healthcare and COVID 19 pandemic, e commerce and product recommendations, and many more. From the vast knowledge and experience of our eminent speaker, let us have an insight on ubiquitous machine learning and its applications. Before we start the today's session, I would like to pay sincere gratitude on behalf of the organizing team to Dr. Someru Sharma, Principal GCET Jammu, for the support and able guidance in organizing this informative session. I thank all the participants for showing keen interest and joining today's session and request everyone to mute themselves. You may post the query in the chat box. Last 15 minutes in session are reserved for the questions and answers. I now request Dr. Nathwani to take over the session. Over to you, sir.
Thank you so much for a brief introduction about me. Let me share my screen. So all of you can see my screen?
Yes, sir.
Yeah. Once again, thanks a lot. Thanks a lot for giving me this opportunity to present one of the most useful topic these days. Like, is everyone is now witnessing the importance and the requirement of machine learning. That is why the title carries ubiquitous. Ubiquitous means everywhere. So machine learning is now everywhere. It's irrespective. It's electrical. It's irrespective. It's computer science. It is actually required in each and every field these days. So therefore, its application is varied a lot, and it is tremendous that we all can now see the importance. So today, with this background, I would like to start with a very beautifully about the outline that what I'm going to present is what is the difference between AI and machine learning first, because this is one thing which people are quite oftenly they use interchangeably a lot. They say AI, they say ML. People don't know the difference, but they start saying AI, ML. So I just want to give a very briefly touch upon that what is actually the difference between the two. Then I will try to give you the basics about that, how you can differentiate the ML problems. For example, we can have the ML distinguish in terms of data, like in terms of data, like what kind of data we are having. Based on that, we can say it is in a supervised or unsupervised, or it's a semi-supervised. In fact, reinforcement has now become the need of an hour. Then based on the output, what you're looking at. For example, if we are looking at the classification problem, so it is said to be a classification problem. ML can be categorized in the either regression or in classification when it comes in terms of output. Then we have a third category, it's based on the model. Model says that what kind of model we are working with, whether it's a generative or discriminative. We will talk about it in more details, very briefly with few examples, and then I will explain the difference between the two. Then I will also give you the importance of the software development, that what are the like different softwares being used in current trend to work with the ML problems. So software 1, software 2, I will explain it in more details about the problems. So let's start with the history of AI actually. And before I go into the history, I just want to give you briefly what is the difference between the AI ML. Initially, people try to use the AI without actually even knowing that they are using AI. So what is the mean that they try to do a lot of rules. They try to set a lot of rules, and those rules were handwritten. So those rules cannot be formulated every problem, cannot be done for each and every problem. So what they need to be done is they need to have some sort of formulation. So the problem needs to be formulated. So this AI is just it's a hand-based rules initially which people were using. This is like the rule-based problems. But then machine learning comes into the picture to do the task of AI. So one should always be clear about that AI, to achieve AI, we use ML tools. Means ML is nothing but a tool for us, which actually avoid making the handwritten rules, or you can say the rule-based, or you can say the knowledge-based rules, which people do in the history. So that is why I started with the history of machine learning or history of AI, is that in the Greek mythology also, one of the first program was an ELIZA. This is an MIT program which teaches the English to ELIZA. Like they were training the lady known as ELIZA, so that how to speak a Queen's English. So this is like one of the initial program was done. And in the Indian mythology, you might have seen this picture lot. Every people have witnessed this picture, every one of us. So you can see that the face, you can now observe the face has been transplanted from an elephant. So again, it's a learning thing. Has been transplanted to the elephant picture. So this is where we can see that we are witnessing the AI, irrespective whether we are doing it or not, but we are witnessing the AI. But now we can realize it also, because now it's a need of an hour. That is why AI is, as I said, machine learning is a need and to do the task of AI. So I hope everyone should be clear about this task, because people use this word very interchangeably, that I'm working on AI, I'm working on ML, this is what we are doing it. But there is this difference. There is a slight difference. There's a fine line difference, that ML is being used to do the task of AI. That's it. So this should be clear to one and all. So let's see that why I said it's a ubiquitous. Ubiquitous means it's been used each and every sector of our life. For example, if you do the search, we can do the search now using Alexa, we can do the Google search, we can actually do the voice commands, we can do the search by voice command. In fact, the 5-year-old child can do the same thing with the help of this, because they do not know what is actually happening, but they are able to use it. Because it becomes ubiquitous, and it is irrespective of the age bar also. If you look at age, is now no matter. AI is being used for every age group. So this is where I said it is ubiquitous, it is everywhere. And if you might have seen that Google, when we tried writing so many times, it learns your text. It actually able to identify what is actually your preferences. What do you mean by preferences? Means, for example, if you search so many times Great Wall of China, so when you write great, automatically you get a typo, like correct, the words come. Have you seen this or not, all of you? Like when you have typed this, you might have seen that, yeah, there is some auto typing is coming. Is it yes or no?
Yes,
Everyone?
sir.
Yeah. So this has been witnessed. So why it has been done? Because we are able to write so many times that Google make your preference list. And how it's doing AI there. It is doing learning there. So this is where I can say that you are actually making when you do the search, you are actually trying to give an input to them. So when you do the input, so they try to make a preference out of it. And next time when you say great, I want to actually, if you want to do this, I want to find the meaning of great. So I cite great meaning when I start writing meaning, it first comes the Great Wall of China, because you have typed so many times. So this is where I can say it's learning so much, so beautifully, that in fact, if you do not want it, sometimes it comes that particular preference. So this is what we can say. There is some disadvantage as well associated with this. Now, another application you might have seen is now becoming very, very useful. It's an autonomous vehicle. So you can see that an autonomous vehicle means there is no person inside. It's just in a car moving, and it has been implemented now in China or in Japan. In 2018, I went to Japan. I saw that there were few trains which were completely autonomous. They do not require any person to be sitting inside. So now you see that this application has been used now. So how they are using? They have they learn the angle. They learn there's a camera associated which actually localize the obstacle. There is a sensor which will tell you that when to brake, when to put a brake, when to change the steering angle, how to do the angle change by looking at the directions. So everything is inside associated, and then we can use the knowledge of AI to do this task. So let's say this is also we have been witnessing that hand writings, like how do we analyze the handwritings? The handwritings has been now becomes very, very useful now to analyze it. Initially, there was a professor in University of Buffalo. This was the first program they started working with the handwriting. They prepared the handcrafted rules to analyze the writing. Then they started moving from handcrafted rules to the more ubiquitous ML programs to do the handcrafted. Instead of avoid handcrafted rules, they try to write them codes which will analyze the writing of and this has been useful in many forensic applications to find out that whether the person has written this or not. So they can identify the writings also. Let's see that this is a very important point, AI paradox. Paradox means that the problem which are easy for people, it's difficult for AI, and the problems which are difficult for the normal people, it is very easy for AI. For example, if you do the you may have to for example, you may have to diagnose the mental disorder. Artificial intelligence has narrow intelligence there. Why? Because this is now becoming very easy for the humans to diagnose the mental disorder. But if you want to find a problem which is tell right from the wrong, means if you have taken a wrong step, what is the right inside that wrong step? It becomes a difficult problem for humans, but it is easy for AIs. So there is actually the paradox. That is why we say that the AI paradox is witnessing in our day-to-day life. The narrow intelligence where people have more intelligence, and general intelligence where people are not having the intelligence to do the task. So this is the paradox. Let's see what are the different tasks require intelligence. So we may see that in terms of sensing, like in computer vision, we sense the objects. We want to track the objects. And also in audio processing, we want to track the signals. We want to classify the signals into different categories. So sensing is there. In order to understanding, that is speech intelligibility, that is a knowledge representation. NLP requires intelligence. And also, if you want to do the activities, some activities like expert systems, you want to make some expert comments or maintain expert recommendation systems, there you require the intelligence, and also in the machine learning. So there are multiple solutions. You can see that illustrative here, like where you require the intelligence. For example, you need cognitive robotics. Now it becomes a very, using the AI help, we can identify the analytics, that is bioinformatics, and also data visualization, recommendation system, and also in virtual agents, you may require the knowledge, you may require the intelligence where human intelligence fails and artificial intelligence is taking ahead. So let's see, everyday life needs knowledge. So obviously, this is the knowledge is intuitive and subjective. So key challenge in the AI is that how we can actually learn the computer. Now, this is where the difference comes, where we initially have handcrafted rules. Now we want to learn we want to train our machine. Machine means our computer. We want to make them learn so that they can do the task. So there we can say that machine learning is going to help to do the task of AI. So knowledge-based approaches are hard-coded knowledge. They are actually in a formal language where you initially used to write the formal rules there, where each and every step was there. For example, if I ask you very simple question, if you want to identify your grandfather or grandmother, how would you do that? If you started looking at the handcrafted rules, it becomes so difficult, like a person of age 50 or 60 plus, or having a gray hair or something like this, or a very shabby walking style. And then a lot of you prepare a lot of formal rules. The hard code knowledge is, you will be doing it, but those are not very effective. Your whole life will spend in preparing that kind of rules to identify your grandparents or grandfather or grandmother. So this has become very, very difficult if you go with the hard code knowledge. So there actually we need some expert systems. Expert systems is like machine learning to do the task for us. So where we need to learn, make the computer to learn and do the task for us. So this is where I was telling AI in the initial days, they have a hand designed problems. You have an input. For example, as I asked, you want to identify your grandparents. So you need to prepare a handwritten rules there, and then you will try to see the output of that. And preparing a handwritten rules is also very difficult to generalize also. For example, if you have prepared a rule for one particular category, it may or may not suit for another category. So this is again a very big problem with the knowledge-based AI, which you require handcrafted rules you were preparing before. Then comes the machine learning. As I said, machine learning avoids the difficulty of hard-coded approach. It makes the computer to learn and give a pattern. So there is a pattern which computer is going to recognize. So there comes the need of a pattern recognition. So machine learning is going to prepare a set of rules which it will teach to the computer so that the now distinguish or classification task or any regression task can be done by the machine instead of the humans. So what are the different steps needs to be done? First, we may have to learn the different types of features. What are the different type of features we may require? We may have to then map those features to the output. Then only you will be able to do the task. For example, if I have a task of classifier, so linear classifier have many ways to do that. There are two different categories, red and blue. But if you follow with the least square method, that is the oldest method which we started with. So you can see that they are actually good if there are no outliers. But if you look at the outliers are here, then the least square is not going to be a good solution. Then we may have to go with the more Bayesian approaches, or you can say the logistic regression. This is where you have a linear classifier. Also, you can have a quadratic classifier where you can have an hyperplane to do the distinguish. For example, you can prepare a Gaussian to fit on these data. Similarly, this kind of data, then you have a quadratic classifier to distinguish the two classes. So these are the useful applications where all of us have actually witnessed the requirement of machine learning. Let's see the generalization of the machine learning is that we may require large number of data. That is one different, very difficult task we may have to come ahead. That the data requirement is the must in the machine learning. In any ML approach, you may require large amount of data because now you are making computer to learn. When you make computer to learn only 10 examples, and those other few new examples have not been taught to the machine, to the computer, so he will make mistakes. So the computer may make mistakes in those categories which are not been taught to them. It's similar for us also. When we do a lot of examples, for example, the maths, we do a lot of practice, then we are able to do the new example. Similarly, we may require large amount of data, samples to be collected. Then we may have to decide which probability or which model we may have to select. As I said, either it's a generative or it's a discriminative. Then we will choose the model. And then we do the estimation of the parameters. For example, when we map the input features to the output, we may have to find what parameters has been used to find this relation. That is, we may have to find the function which has produced this output. So those parameters needs to be estimated. Then comes this is the training stage. Then comes the decision when you try to make an inference on a new set of data. It may be very important to note here that your data should be different in this category because you cannot make an inference on the same data which you have trained it. If you do that, the 100% accuracy you will achieve. This is good for checking purpose, but not good for the inference, because if you want to see whether your model has been trained properly, you may have to test it on a different data rather than using the same data which you have used in the training. So let's see the one very simple problem. If I want to do the fraud detection on the credit cards, this is very useful problem which we are witnessing like every day. And so we may got a lot of fake calls and which they ask your frauds, which ask your details of your credit card. So this is, we have witnessed also. And now let's take one example very quickly that we have to improve the performance. Performance of what? Performance of finding the accuracy of the fraud like which has been made on the credit card. And how you will do that? You will execute some task there. T is your task. You will assign some calls is fraud or some calls is not fraud on the credit card transactions. So you may have to assign a label. This is where we can say that we have a ground truth beforehand, whether this is the credit card transaction is labeled the correct one or is the fraud one. So you have to put the labels beforehand. Then you do the performance and you will train the experience. You will use your experience to make a new labels on top of it. So this is where you can actually learn to detect the credit card fraud. So as I said, there are different ways to deal with the ML problems. One is based on the data, like supervised, unsupervised, reinforcement, and then based on the output, that is your regression, classification, and also on your model, generative and discriminative. Let's see, this is a very beautiful picture I have bought from the internet. You can see this is a periodic table of ML algorithm. Like we have our chemistry, if you have gone through the chemistry course, which you in your +2. So you might have seen there was a periodic table. Here is also we have a periodic table which talks about which talks about your regularization, what are the different categories in regularization, classification, different classification methods. Then we have a supervised and unsupervised, or both supervised and then reinforcement. So what are those categories come in those particular cases? So this is, you may look into it, and if you want, I can share these slides also with you so that you can have a clear idea about those categories. So let's talk about the supervised learning first. Briefly touch upon it, where we will say that supervised are those categories where we have the information about the labels. Like for example, as I said, the credit card fraud. So we have some initial samples which tells you, okay, these are the few transactions where we say that it's a credit card is a fraud one or it's a not a fraud one. So those inputs has been provided beforehand. With those super data, you can actually train the model using those input and the output and try to learn the parameters. And when you have the knowledge of the label, we can say it is a supervised learning. The one important thing is you can have multiple label on a one particular category, one particular input. For example, you say fraud, what kind of fraud it is? Is a fraud call or it's a fraud credit card? So you can have multiple labels in one particular category also, which is possible these days, where you have multiple labels or more than one class is associated. Then you make the ranking, which is more important, which is not important. So based on that, you can actually try to find the mapping between the input and output and learn the parameters, as I already told in the previous slide. So let's, I would like to skip this problem because this is a very basic problem. Let's talk about how do you learn the supervised by using the gradient descent approach. So you may look into the very simple problem where we have an fx, which is our function which we want to minimize or maximize. Okay, so fx is half x square. Okay, this is my blue line is my fx. If I take a first gradient, so you can see there is a line coming here, which is x here. This is a simple maths here. So this x comes here. So you can see this is a line on which this gradient touches upon. So at the point x is equal to 0, there is a cut. You can see there is a cut here between the two, and less than that is the category where x is less than 0, and above than that is the category where x is greater than 0. If your function lies here, if let's say for x, if your point lies here, so you want to make it to this point, so you will increase the gradient. You will move in the right direction. If you are, let's say, on the right hand side and you want to move it to this direction, so you may have to decrease your function f by moving leftward. So this is how where you will achieve the global minima, where you can say, okay, now I started with here and update my weights so that I can reach to the global minima, where it is this point in between here. You can see this is a minimum point, and this is done after some iterations. And you can keep on changing your weights at each iteration and then reach to this point. So this is an advantage of supervised learning by using the gradient descent approach. This is one of the simplest way I can say to achieve global minima by using gradient descent approach. So let's move on. Another ability to generalize. Again, it's very important, as I said. The initial hard code it becomes unwieldy process, because for each example they have to make a new set of rules, which is very, very difficult. So how to avoid this? ML comes into the picture, which it has an ability to generalize on multiple number of data. So for example, if I have to do the handwriting recognition, so what I'm going to do, let's say this is the only task, this is the only one set of data I had. So what I'm going to do, the augmentation of the data. What do you mean by augmentation? I have to increase the samples for the input data set. I can do that by translation, by rotation, or by scaling. I'll give you a very simple example. Let's say I'm working in speech. I have one particular fundamental frequency. This is the only data with me, and I want to train it. So what I'm going to do, the data augmentation, I change my pitch. When I'm going to change my pitch, my voice is going to be completely different. So similarly, I can speak slowly. I can speak like this. For now, I'm speaking in a normal tone. In very slow tone, I will be speaking like hi, how are you? So this way I can change the rate of speech. I can change my pitch. So there are many ways to augment the data. So this is what I'm saying. When you have less data, this is also one problem comes in a realistic scenario. So what do? You do the augmentation of the data available with you. And then you avoid also when you also important point is when you also come into the situation when your model is being overtrained means your loss function started decreasing, your training loss function started decreasing very less. Then you have a data set known as validation. From there you want to see the loss. If the loss generalization not becomes a generalization, it becomes a biasing towards some categories. So we do not have to do the biasing also. So this is an important point here. Let's talk about the unsupervised learning. As I said, unsupervised, there is no way that you have any information about the data, that is the labeled data. There is no labeling performed on the data. For example, if I want to do this category of fraud detection, the data which you have been provided, there is no way it has been mentioned that it is the fraud, it is not fraud. You have to obtain this information using the underlying structure. That is one of the ways you do the partition of the data in two categories first. You find a mean of them and then get put in two different categories. One is M1, one is M2. So then you put them in that mean. If that left hand side belongs to one category, right hand side belongs to second category. Then again you have, this is one particular class. Again you update the mean. So this is known as k-means clustering. So you do multiple clusters, prepare based on the updated means. And from there you able to know, okay, there are 3 classes or there are 2 classes, depending upon that. Because here we do not have any access to any information about the labeling of the data. So there you can actually do other approaches. This is known as k-means clustering, which is very popular approach. And other approaches like you can actually project the data. That is, if you have a large dimension data, you project into the low dimension by using PCA or autoencoder, and now you can do the clustering there. This is again very easy way to solve this problem of unsupervised labeled data. What do you mean by semi-supervised? Semi-supervised means some of the data samples has the labeling, but the rest of them has not. So how you will improve the performance? You start the training with the some sample data which you have the labeled. Then again, you do the you try to find the label of the new data and try to improve the performance by bootstrapping. For example, I have let's say 20 samples, 10 of them are labeled, 10 of them are not labeled. So you start with the 10 and improve your accuracy, improve your modeling learning rate. Then once the 11th data you have, you try to find the label for that and again train the model with 11. Now initially you have a 10, now you train with 11 with some labeling which you have done. This way you can actually bootstrap it and then do the semi-supervised method to do the task, because this is also very realistic. Sometimes you may not have the full label data. You have only few labels. So you start with a semi-supervised approach. Then comes a reinforcement where you have an action associated with each and every data. For example, you may have some action, may have some policies which help you to take a decision in a particular situation. So you will have, this is actually in between the supervised and unsupervised. So you actually have some associated action. So you say, okay, action is correct or not. So there's a reinforcement comes into the picture, and you appropriately you choose an action based on a particular situation and then improve the learning accuracy. So this is not important. Let's take very simple example of regression. As I said, now the third category is based on the whether the output is a regression or a classification. So in regression task, we want to learn a new thing. We want to predict a new thing. We want to predict from the past experiences. When a new data comes, we want to predict it. For example, if this set of data is being given, I want to predict a curve which derives which tells you how this data has been produced. Means a function which has produced this data. So this is a very well-defined problem. So regression says you may have to find a curve which best defines this data. Here you can see on the right-hand side, it is not a good curve because they have over-tuned it or they have over-learned it. So this is why we can say that this is not a good curve fit to this particular data has been given. So this problem says that, okay, I have few data set beforehand, I will train it and then get the parameters trained. When a new data comes in, I want to find an output correspondingly. So this is where I say, okay, I want to find a function first. And when a new data comes in, I will produce a new output from that function. So this is very simple way of explanation. Regression also has an important task is to learn the rank. As I already told this problem, when you type so many times on Google, Great Wall of China, Great Wall of China, Great Wall of China, it will learn that. In fact, when you type great, it will auto type and give you the Great Wall of China. So because you have number of times you have frequency, the frequency of your query is an important parameter in regression. And also we have a URL, number of times you have typed a particular URL, that is also an important point. And what is the page rank also gives you an idea about the ranking of that page. And what should be the output? Output tells you the relevance of that value. It gives you the rank of that word. So if you put Great Wall of China multiple times, it will learn that. And when you only put wall, it will also take Great Wall of China completely because that has been ranked 1 in this case. So these are few examples which students might be of interest to can take it like how to first make a rank of those features. What should be the input feature so that ranking becomes higher in that case. Now we have seen the two paradigm. First was the hand coded where you have a conventional AIs was used. Then we have a machine learning to do the task of AI where we have still hand design features which we map from the input to output. But this hand design is not a good idea. So we transform this classical machine learning to more advanced one where we learn the features. So let's see, we learn the features and it is an important task is the designing the right features. Because if what happen if in case you choose a wrong features, so your task has been not done properly. For example, if I want to detect a car, if I take a picture like this, you see a person is coming in between the picture of car and him. So this is where you can see, okay, my features are not proper here because it actually carries the image or you can say the features of person, which we are not interested in. So similarly, if you take a picture like this, this is a tire coming. So there is a some shadow is also there. There's a blurring is there. So tire shape you can see has some shadows. Glare is also there. And also this is not a right feature because it's an angle is also playing a very important role. So image, what you are taking for putting an input for your machine learning plays a very, very important thing, means the features. So we will talk about that the features can be very, very useful and also in representation. For example, as I said, you need to make a representation between these features to output. So you need to have an ML not only learn the mapping function, but also to represent the features. Nowadays, people have actually advanced to a very high level where they started using end-to-end models. They don't try to learn the features separately and then feed it into the DNNs. No, what they are doing is inside the neural network, they feed the raw input. Raw input, for example, if I work with a speech, so I have a raw audio waveforms. I don't compute the feature first. It is inside the neural network with the features or computation. So the better representation has now become the key. Now people have to try to learn the representation of the feature inside the neural network rather than taking as a separate step. Let's take one example. This is a picture I want to classify into a car or a person or animal. We all know this, but does machine knows this? So this is where we need to try to go and hidden layer where the representation of features becomes more and more important. For example, if this is my first layer, which is a visible, you can see from the input pixels, it is not clear whether it's a car, person, or animal. But again, after first layer, you learn the edges. You learn the edges there, and you have second hidden layer learns the corners and contours. You can see more clarity or representation is coming. The third layer you can see there, sorry. I'm sorry. Yeah. For the third layer, you can see more clarity comes into the picture of a car, which has the tire there. And there is a picture of an animal there, and this is a picture of a person there. So you can see the clarity comes. Now, maybe people may ask, sir, why do we need to have more hidden layers? Now the answer is very clear. In the first hidden layer, it is only the edges which you are able to predict. The second hidden layers, you have a corners and contours. The third hidden layer becomes a more on the objects oriented, which we can see now I can see an object there. Now more probability is this, that this is my person, and this is my animal, and this is my car. So this is where I can say that the series of hidden layer makes your feature representation much better than one single hidden layer. Let's talk about more and more on the hidden layers. Then it comes to a picture of deep learning. That's why the deep neural network is distinguished from the conventional machine learning approaches, where now you have more better representation of the features. Now you have one layer here, second layer, third layer, fourth layer, fifth layer, like this. You have multiple layers, and at each iteration, at each layer, you try to learn the weights by the gradient descent method, which you want to minimize till the minimum. So this is where you can actually do more and more task of adding the layers to have a better representation of the features. Now, this is a summary. Summary says what we started with is then artificial intelligence was a rule-based. Then we have a classical machine learning where we still have a handwritten features, hard-coded features. Then we have a representation learning where the features were extracted by some different methods, and then which we find a mapping. Now we have a more deep learning where we have a better representation of those features, where we add more and more layers to have a better abstract features. Now, hope you have seen the transition, or you can say the revolution, how this has been come into the picture, starting from the rule-based to the representation. Now, AI paradigm shift is not only in physics. It's the paradigm shift is not only in AI, but it's also in the physics also. You see that we have the initial, black body radiation was not clearly explained. Now with the colored, we can see the quantum mechanics has come into the picture, and the clarity of the understanding the black body radiation has been improved. Similarly, the AI paradigm shift, we can see that is starting from the knowledge base, then simple machine learning base, then we have more on the representation based, which we are able to now improve the accuracy of the classification as well as the regression task. Now we'll talk about some time on the software area also, because people always think about that ML. If you know that, you need to know a very good, strong, like exhibiting the strong knowledge on your software skills, or you can say the programming skills, which is must now for doing the task of AI. So you can say ML is a programming computer for AI, as I already informed, that you may have to do the task of human, but here you will try to generate the algorithms. Here to generate the algorithm and make the computer to learn and try to predict the outputs. Now, similarly, ML has now been utilized in each and every aspect. Like you can see in the scientific and engineering application, it's also been in the banking now, it's being in the IRs now, it's everywhere actually, ubiquitous. That's why the name is ubiquitous. Now let's talk about something about the software. Software one was a classical when we have the initial Linux and the Python were used. Now we are more into the more on the optimizers actually. What do you mean by optimization? Optimization means you may have to do the task of finding the gradient descent, where you want to find an optimized weight there. So you not only you know the knowledge of Python, but you also need to know multiple optimizers. For example, mean square error is one of the optimizer. And you have KL divergence is another optimizer. So multiple optimizers knowledge, which has been added into software 1, so that software 1 has been now moved to software 2, because it has the basic knowledge as well as the more on the optimizers as well. So initially programs were writing in the simple C++ programs were used for software. Now we have more on the TensorFlow. That's why I said the optimizers come into the picture, where you can actually do the ReLU and you multiple the activation functions you can try and then learn that. So these are the transition has been made from software 1 to software 2. Now, as I said, the optimization is now become a need of an hour, and the software 1 was only a simple space which you were working with. So initially the coders were working with the Python Perl, and then they feel that they are very well versed with the software. But now the software knowledge has also been enhanced. People starting from the simple software now have to move on to the more onto the advanced optimization like stochastic gradient descent, Newton-Raphson methods, and then software has been changed from 1 to 2 also in the space you can see from here in the programming domain. I'm actually trying to want to make you aware of that now. The basic knowledge of Python and other things, it's okay, but you may have to move one step further where you can actually learn the optimization to avoid taking longer times, because the complexity has now become a very important point. All these big companies, multinational companies, IBM and other TCS and other companies are now trying to look at the how you are coding in a very efficient manner, and you are able to achieve the task with less computational complexity, because this is where in the realistic scenario when they want to deploy the solution, they need to see this. If you take for a simple task 1 hour, these people will not appreciate that. So if you do it in a 5 minutes, they will appreciate, or even less than time, it is even more appreciable. So this is where we can say the software has now been moved on from software 1 to software 2, where you can actually try to do more portable things. You have less running time, and also you have computationally inexpensive also. So there are some limitations. Obviously, everything has not all this positive, but there are some limitations also. So let's see that software 2 has now been the need of an hour, but the point is that they are finding it difficulty in interpretation. In interpretation means how you can say it's a 90% accurate model we understand and 99% is not understandable. So this is where we can actually, the interpretation problem is there, where the knowledge of a person will come into the picture to better interpret the situations. So software 2 has an advantage, but interpretation is the one issue which may look into it. So how ML disrupts the computer science actually? Now this is a very important point. The software development has now become the has taken up from the ML and move on to the into the higher stakes, where you can see that the present initially we have working with the sample tangible codes. Now the future is like people, the teachers can curate the training data and then try to learn the results, analyze the results very in a very quick time. And mathematics also has been like developed, or you can say the revolutionary change has come from initial. We used to have the calculus. Now we have more onto discrete mathematics. Similarly, the future has gone into the theory of probability theory, and linear algebra has come into the picture. And also the hardware also. Initially we used to have a CPUs. Now we are more onto the GPUs. The cluster of CPUs have been now, and also the software, as I said, from software 1 to software 2 has now been the transformation has been done in the in not only in mathematics but also in every other fields. So this transition has now like the need of an hour, as I said, because now people don't store the data there. They don't work on their own system. They try to GitHub, try to prepare a GitHub code, put it on there. People are appreciating the GitHubs now because they are able to get the codes for ready usage, and they tells you how to use that code. So now if you might have seen the paper, when we do the summation of our research papers, first thing they ask now is the reproducibility of your code, because now it has become an art. It has become actually, they don't see that, okay, you have submitted something. They need to see whether the results what you have put in your manuscript or that has been correct or it has been manipulated. So this is where they want to see the reproducibility of the results. So it's not only the ML has AI has been translated to ML, it's everything which we see that the transition has been done. So let's quickly talk about the ML models, which now has moved on to the probability theory. As I said, the mathematics has also been transitioned. So now everything is on probability. So and ML rely on the probability theory. So let's very quickly touch upon the probability theory, which starts with the sum rule of marginalization. If let's say if my if I have two events, let's say X and Y. If I want to find an event of the probability of what is the probability that event X is occurring, so what I can do, I can sum over Y and I can probability event of X. So this is known as the marginalization. So you can say that J has been summed over all possible values which it's carrying. So this is P of X. Similarly, if I want to find the combination of the two events are occurring, so I can say Nij, which tells you the number of occurrence of X and Y together over n trials. So this is where you can see that it's a joint combination, or you can say the joint probability distribution. And you can say it is the simple base rule is Py by X into Px, which gives you the joint distribution. And here, actually, this is where I said when you do the generative learns this joint distribution. When you talk about the discriminative does not want to know how the data has been generated. They directly learns the posterior P of probability of Y given X. So this posterior is probability of X given Y into probability of Y over probability of X. So we can say P of X is difficult to model. So what we can say, the posterior is directly proportional to the likelihood. That is your probability of X given Y into the prior information about the Ys. So this is your Bayesian approach, which has now become the need of an R, where each machine learning relies on this probability theory. Logistic regressions are depending upon the probability theories, and other approaches requires the probability theory knowledge. As I said, from X to Y, this is probability of X comma Y there. But discriminated does not require this information. They directly learn the probability of Y given X, that is your posterior, so directly from the data itself. So what are the different methods comes in the generative? That is naive Bayes, HMM, Bayesian, and what about the discriminative? We have logistic regression, we have neural networks, we have NN nearest neighbor, that is KNN, and also the conditional random fields or random forest approaches comes into this categories. Now, finally, I would like to summarize my talk that machine learning is, again, as I said, it's different from AI in the sense that machine learning is a way to do the task of AI. AI was initially the knowledge-based systems where you need to do the handwritten codes. Now, machine learning is try to do the same task by preparing the representation better or the features and try to learn them from the data itself. So, and different categories of AIs can be done is like supervised in terms of data. We have supervised, unsupervised, output is classification, regression, and in terms of modeling, we can have generative or discriminative. Finally, softwares we talk about, the different softwares we have transitioned from software initially like 1 to software 2, we have moved on to that. So many thankful to you for being patient listening, and I'm open for the questions. Thank you very much.
Thank you, sir, for a very informative and wonderful presentation. I am sure the audience has been extremely benefited by the knowledge shared by you. Over to Engineer Prabjot for question and answer session. Sir, kindly unmute yourself.
Thank you, Karan sir. Now I would like all the students to please raise any question if you have any.
Prabjot, one question is there in the chat box. You can read it out.
So, sir, there is a question from Inam Gulzar. Okay, whatever the ML produces, it is tangible in human language. Can we
Yes.
reproduce it?
Yes, it is. It is tangible in the sense that nowadays you might have seen the speech recognition at Alexa. You might have also observed that. So it is actually tangible that whatever you are saying, it is actually recognizing it and giving back the information as if it's a human person is talking. You are talking with a human. So it is tangible.
Okay. Thank you, sir. So, sir, there is one more question. Is there a way to estimate the maximum or minimum number of hidden layers to correctly model a problem? So, is there a way to find the maximum or a minimum number of hidden layers?
As of now, the number of hidden layers is also a kind of a research. People are trying to look at that how much deep you want to go. That question is still unanswered because with an experience, I can say that people have gone like one step further. They try to locate that whether a representation is better in second hidden layer or in third hidden layer. They try to localize and then see the performance for each hidden layer, and they stop at that moment when the representation is much better. Although there is no closed form answer for this or closed form solution which says that okay, I need only 2 hidden layers or 3 hidden layers. So how much deep we need to go, it's still a question of a point of research.
Okay, thank you, sir.
Sir, I would like to request you, sir, थोड़ा सा अगर आप बच्चों को guide कर पाएं so that they can take this as their research project और क्या इसके थोड़े से हैं ताकि these
Sure.
some क्योंकि 7th semester and I think 5th semester students and 3rd semester students are there so that they can think about it, how they can use these paradigms.
So have they gone through some basic machine learning course in their curriculum?
Yes, sir. Yes, sir. They are doing something in MOOC or online courses, and the 7th semester is they are studying the course.
Fine. So what I can suggest here is like they can contact me via through you, or they can contact me directly also. We have some internships kind of thing. We can do that. It will be unpaid, means it's a free internships, but they will learn a lot because on a realistic scenarios, on a realistic problems, they can work. So I can guide them.
Okay. So,
Sir, one last question, sir. A mechanical student has raised this question. Is ML good for mechanical students to learn or not?
Important area where ML has been required. So robotics is like in ML, it's a you can say that it's an interdisciplinary area where mechanical and electronics come into the picture. So, and ML is, of course, as I said, it's a tool to do the task. Yeah. Anything else?
Definitely, Siddhant, sir will help you in your project. So I will share his number, and Karan, you can share the internship details with me so that I can share with my students.
Sure.
So sir is always available. He's very kind to accept my invitation. Very short notice invitation, I must say.
It's okay. It's a pleasure to be to discuss with all young minds, and then if they have any questions or queries, please discuss with me offline. So I would be happy to answer them.
So thank you, sir. On behalf of my college, I extend my hearty vote of thanks to our guest, Dr. Karan Athwani, for sparing time from his busy schedule. Sir, we have no words to offer gratitude from your valuable presence here. You gave deep insight into the artificial intelligence and various models of learning, techniques of generalization and regression, and revealed various interesting facts that how ML model rely on probability theory. I want to appreciate your efforts for making this session very informative for all of us. I'm thankful to Dr. Bhavna ma'am and Engineer Sheetal Gandotra for conducting this webinar. We are very fortunate to have the team of very dedicated staff and practice students. I am short of words for their involvement and their willingness to take on the completion of this event beyond their comfort zone. A special mention of our respected principal ma'am, Dr. Samiru Sharma, and our HOD, Dr. Simidatta, for being the catalyst that stimulated us to do our best. With deep sense of appreciation, we thank all the students for being with us. It has remained a pronounced pleasure. Thank you. Have a great day.
Thank you, Karan. And one interesting question just popped up here on the chat. Sir, will AI go beyond human imagination in future? Before we end. Hello, Karan. Are you there?
I am here. Hello, can you hear me?
Yes,
Yes, sir.
Karan.
Yeah. So it is really interesting that, and I would not surprised to say that it is possible. It is possible that I have seen the facts also. Like as I told in my lecture also, when I was in Japan for a particular conference, I went there. I was using their metro, so it was completely unmanned. So there was no. It was completely autonomous. So it is now becoming. You can say that it is now replacing the man, replacing the human's imagination. And I think it's a advantage as well as disadvantage. In the sense, advantage that it is more accurate, disadvantage that it is reducing the jobs opportunities. If the man is not required, the jobs will be less in that case. So this is you can say the trade-off between the two.
And one more thing I will add, sir is from electrical engineering department and sir is master in ML. So I think anybody can be master in ML. Sir is a
it is beyond,
live
beyond
example.
This. Yeah, it's
Sir is
beyond
a live example.
Yeah. So it is not like that ML is only for CS. No, it's a wrong misconception actually. When I was in France for my postdocs, I was working on ML, and then all of them were having interdisciplinary areas. So my area is like an interdisciplinary where speech and signals all required. So, and it's a computer science, it's a mechanical, it's a electrical, it's everything is incorporated. But yes, we are BTech from electronics communication, but masters of you can do anything in that. Yeah.
Thank you, Karan. Thank you so much.
Thank you so much. Yeah.
I think we should conclude the session.
Thank you so much once again, and nice talking to all of you.
Thank you.
Thank you, sir.
Thank you. Bye-bye.
Thank you, sir.
Thank you.
Thank you. Thank you so much.
Thank you. Bye-bye. Can I leave?
Yes, sure.
Thank you.
Prabjot, share the Google form, attendance form.
Okay. I am sharing the feedback form, ma'am.
Yes.
Okay.
So thank you, students. Thank you, my team. It was a wonderful session. Hope you enjoyed it and you must have learned few things from sir. And hope we'll conduct such sessions again. So we are sharing the feedback link to all
So I'm
students.
sharing the feedback links in the chat box. So all the students are requested to please fill it.
Okay. So those who will, all students, it will be open for just 5 minutes. प्रभजोत 100 यहाँ पर है और I think 10-20 students हमारे YouTube में join किए हुए हैं.
Okay.
So just
So your attendance will be marked based on your feedback link. Okay.
Inam, you're from which branch? Okay, 5th computers. Okay. Fine. I will take his email ID and his LinkedIn details, then I will share it. I have a contact detail, so I will share with you. You just message me. You have my number, right?
Like in the feedback form, there is a field designation. So I think students can write student
Students.
in that particular field. Yeah.
I think अच्छा हो गया प्रभजोत, है ना शीतल?
Yes, ma'am.
Short and sweet.
Yes, yes.
Thank you अर्शिया.
पार्टिसिपेंट्स भी हो गए थे. YouTube पे कितने पार्टिसिपेंट्स ने ज्वाइन किया मैम?
YouTube में हार्डली, जब मैंने पता किया था तो 5-6 बच्चे ही थे. चलो
और यहाँ पे 100 प्लस.
यहाँ पे 100+ हो गया था. चलो थैंक यू सो मच प्रभजोत. आप थोड़ी देर तक अभी ऑन रखो मीटिंग, तो आप चेक करते रहना. ऐसा ना हो कि ज्यादा बच्चे फीडबैक फिल कर ले. तो फर्स्ट 120 आते हैं तो जस्ट क्लोज द फीडबैक.
ओके मैम.
थैंक यू अर्शिया, इट वाज वंडरफुल स्टार्टिंग.
Thank you, ma'am.
क्लोजिंग एंड स्टार्टिंग बड़ी मजेदार. बीच में तो सेशन रहा. थैंक यू.
Thank you, ma'am.
ओके.
Okay.